For this question, if you are rolling a dice, then your probability of getting any number on a six-sided dice should be 1 in 6. So if Pedro thinks that he has a better chance of getting a 3 more often than the other numbers, then what he's saying is that his proportion of times that he gets a 3 will be greater than 1 in 6. So for your null hypothesis, your null is always that everything is always equal, that there is no significant difference, and it's telling you to write your P as your proportion for your population. And so I think, I'm not sure how they want you to write this, to be honest. Maybe you have other examples from your notes that will help you with this, but I think what they're getting at for your null is that the population proportion and the sample proportion are equal. That's always how we have to write a null hypothesis, is with an equal statement. And for the alternate hypothesis, in this case, he is trying to say that his P is greater than the population proportion. So big P, little p there. I'm not sure if they want you to actually use numbers. If they do, then for the null you would have to write that his P is equal to 1/6, and for the other one you would have to write his P is greater than 1/6. So again, if you can look back in your examples from your notes from your lecture, you might see how they want you to phrase that before you type it into the box, okay? Now suppose Pedro makes 42 rolls and a 3 comes up 9 times out of the 42. Alright, so what's happening here is the proportion that's actually happening is, I'm just going to write over here, 9 out of 42. And we're comparing that to what should happen, which is 1 in 6. So if it was 42 rolls, we would expect it to be 7 in 42, right? And so they're asking us to determine the p-value of the test, which means that we need to compare those two by subtracting them. And he's actually getting 9 out of 42, and we should get 7 out of 42. And you need to find your sigma the same way that I showed you in the previous example. So you're going to use that to find a z-score, which you're then going to look up on your chart to find your p-value, and that percentage from the chart is what you're going to put in your box there, okay? Now, does this sample provide evidence at the 5% level that Pedro rolls a 3 more often than you'd expect? So you're going to answer yes or no to this. I suspect the answer will be no, but you'll have to work it out by finding your test statistic, and that is, for part C, you're going to be looking for your z-score at the 95% significance level, okay? And I think that you guys have a chart with all of those in it, like the 1.645 and the 2.57 ones. You're going to find the one for 95%, and you're going to compare that to the actual z-score that we got here. And if it turns out that Pedro's score is in the critical region, so that your z-score from here is greater than this z-score, then you would say that yes, there is evidence to suggest that he's getting 3 more often than he should. If it doesn't, and it leaves him in the normal region, then you would say no. That would mean that his z-score is lower than the test statistic z-score, and you would say no, there is no evidence to support that. So I hope that helps, and again, if you look back in your course notes, I'm hoping that you'll have an example that will explain to you the format they're looking for there. I'm just kind of jumping in out of nowhere, so I don't really know exactly what you're expected to write in terms of the form of that one.